Hey everyone, welcome back to another video. It's been a couple of weeks since the last one where we covered blueprint interfaces, which is something we're not exactly going to use here specifically, but we'll take another look at towards the end once we finish our puzzle. But what we're going to do in this one is we're essentially going to create a fuse box puzzle. So you've got 3 fuses, or in your case you might have as many as you want. I'll show you how to extend it. And we can place them inside the box and they'll go to the correct location and then it'll activate the puzzle. So if we jump right in, you'll see that we can actually go up and we can pick up our fuses. And if we do the red one first, so I picked up the red one, you'll see that if we try and put it in the blue slot, nothing happens, same as the green. But if we add it to the red slot, it actually attaches and goes in, nothing happens. So if we put all 3 of them in, and we have a look at our light, once we add the 3rd, it actually activates. And the best part is as well, we can actually go in and we can take these back out and we can turn off our light. So, oh, I dropped it. So in this video, we're going to cover how we can maybe add these into the scene and set all this up so you can do it yourself. So before we get started, if you're a Patreon, you can actually download this file now. It's going to be just a little thing that I'm working on, which is going to start containing all of the tutorials in one. So you can go in, you can break them down, see how things work with each other, and kind of use it how you wish. So, first thing we need to do is get a blank project, and here's one I made earlier. Sweet, so we're good to go. This is exactly the same as, this is the base VR project. We're going to essentially build on from the Blueprint Cube pickup, and we're going to create our own. So this whole thing works with 3 blueprints. So let's go to Virtual Reality Blueprints, and we'll keep this organized. So we'll create a folder. We'll call this Fuse Box Puzzle. And we'll open this up. And in here, we're going to need 2 actors. But one of them we technically already have. That's the Blueprint Cube. So the first one we're going to create is a Blueprint class. We're going to do actor. And I'm going to call this blueprint, and we'll call this fuse box. We'll hit enter. And rather than recreate the cube from scratch, we're going to browse to our set. We'll drag it into our folder, and you'll see it says copy here. We're going to do copy here, and it says 1 item copied. Excellent, so we've got a copy of our cube. I'm going to rename this to blueprint underscore fuse. Thing is, if you're doing let's say it's a sci-fi project, this could be a canister that you've got to place into a location. It could be a picture frame that you place on a wall. This is super expandable to whatever it is you want to do, essentially. So what we're going to do is, now we have both our blueprints created, we're going to go to our fuse box and we're going to create a reference for it. And by that I mean we're going to add a cube that we can see. And I'm going to scale this down just so we can place it on the wall in our scene. So it doesn't have to be perfect. Hit compile and save. And you can see we can rotate that around so we've got it on our wall. And for now, I'll do what I did in the example project, and I'll create a little shelf that we can actually put our stuff on, just to make testing quicker. So if we press play in the viewport, we'll spawn in front of it, which is great. And now we can actually start building our content. In this case, the first thing we're actually going to start with is the fuse box, because I want to show you how it communicates with our pickup actor to function. Excellent. So if we jump over to the event graph, first thing we're going to do is delete all of these. There it goes. What we're going to do here is we're going to create a collision box, which once our object touches it, it sets the position and then adds 1 to our score, essentially, that allows us to open the door. if you watch the previous tutorial on blueprint interfaces, it's the same thing that we did for the win event. So we add a number and then we can open it. So as mentioned, the first thing we need to do is add a collision box. We'll go to viewport, and I'm going to scale this down just so it's visible. And what I want to do in this case, I want to make sure it's a square or close to, and then have it placed just in front of the box. And for demonstration purposes, I'm also going to set it to show in-game. So when we press play, we should be able to see it. So if I just simulate, we can see our collision box. This just lets us know where we can attach our fuse to. What we're going to do is we're going to rename our box. Rename fuse. We'll call this fuse location 1. So then we can add as many as we want. Hit compile. Now if we scroll down on the right, we want to actually use the begin overlap and the end overlap. So with the fuse selected, we can select these and we'll get one of each in the scene. Now what we need to do is actually get a reference to the fuse that we want to interact with this box. So in this case, it's going to be our blueprint fuse, but we're going to set this in the game. So if we open this up, I'm going to set our static mesh. So this is just our fuse to cylinder, and then hit compile. So we can drag this into our scene. Let's make it a little bit thinner. So we'll do 0.1, 0.1. Oh. So all I've done is change the scale of the cylinder and set it to 0.1, 0.1. Hit compile and save. And you can see now we have something that looks like a fuse that we can add into our scene. And the best thing about this setup is we can actually duplicate this exact blueprint, change the mesh, and then have as many as we want. So we'll do that later on. There's no point jumping ahead, but we've got our fuse. That's exactly what we're after. We can pick this up and we can interact with it. But what we need to do is actually have a reference for our fuse box to know. So what I'm going to do is I'm going to select variables. We're going to create a actor object type and object reference, and I'm going to call this fuse required. Hit enter, and you'll see that we can't actually add anything to it yet, so we'll hit compile. Now we've got it. Thing is, this actor we can only set in our game. We can't set it here. We'd have to get it, set it, and then do some magic to make that work. But what we can do is if we select our blueprint and we make sure our fuse required is public, we can actually now select the fuse in our scene that's required for this first box. We're going to get a reference to it, and we're going to check that our other actor is equal to this fuse. So if our fuse overlaps this box, we're going to set it to a branch and set it to true. So we'll do equal, plug it in, and we're actually going to do the same thing for the release because we need to know that it's this. So the next thing we need is a branch. I'm going to drag off, and we'll do the same thing for the bottom. And now what we need to do is actually set some stuff up in our fuse so we can cast to it and we can set a variable. And to do that, we need to actually go into our fuse, go to our event graph, and we're going to modify some stuff on our pickup and release. Actually, what we're going to do is we're going to open up our fuse and we're going to create a couple of variables. In this case, the first variable is going to be is fuse connected. If we bring this in and we do a get, and then we can do a branch, we're going to connect this to our event drop. So what we're actually doing here is we're going to check to see if our fuse is connected to the box. So if it's touched the box, it's going to disable the physics and it's going to set the location. If it hasn't touched a box, then it's going to go through the code as it normally would for the drop item. So if fuse is connected, we're going to go through and set simulate physics to false. But if the fuse is not connected, we're going to go through and we're going to set it to simulate. So fuse is connected, true, it will hold its position in air, so it won't fall to the ground. And then if it's not connected, it's just going to fall. Same as a physics object. So let's keep this tidy as we go. What we can do now is we can actually connect our set simulate physics from our false channel directly to our detach from actor. But what we need to do now is we need to set the world location for this blueprint when it touches our box. And we're going to do that by getting a set actor location and rotation. So if we do set actor location and rotation, we're going to plug that in here. Connect that to our detach from actor. And we'll keep this organized as it is. And you'll see now we need a new location and rotation value. We could create two variables and have them set through a cast or a blueprint, but that's just a little bit unnecessary for this case. So what we can do is we can actually select our pickup actor interface, our drop, and we can add two input. And in this case, we're going to set these to set drop location, or it'll be set location and set rotation. So our rotation will use a rotator. Now set location will use a vector. And now what this allows us to do is if we go back and we check our event drop, we can actually send location and rotation information through this function to our new set locations. So we might as well keep this organized. Excellent. Now we can hit compile and save. And because we're using a function and we've added the set location and rotation, if we were to actually open up the pickup cubes, so let's open that up, you'll see that's actually added that information to it as well. But we're not using this, so it's not going to cause any compile errors. So we don't have to worry about it. So you can see how you can use this for multiple different things. And for our fuse, I believe that is actually it. So if we cover this quickly, what we've got going on, we have our event drop, which we're going to set location and rotation. We're checking if the fuse is connected. If it is, we're disabling physics and we're attaching our set actor location and rotation. So this will be in the collision box of our fuse box. On false, we're setting the physics to enabled and then detaching from hand. Same as normal. Hit compile and save. And now we can go back to our fuse box and we can start setting some information from the fuse that we have set. So we're going to cast to this fuse rather than just using the drop. We're going to use a bit of both. So we cast to our fuse and then we're going to set this value here. So is fuse connected? And we're going to do this for both our begin overlap and our event end overlap. So what we're going to do is we're going to drag off our fuse required. We're going to do cast to BP and we're going to cast to our fuse. And essentially we're casting to a specific fuse that we have selected. We'll hit true. And before we copy it down below, we're going to drag off the BP fuse. We're going to go set. We're going to go set is fuse connected. And for our begin overlap, we're going to set this to true. And for our end overlap, we're going to set this to false. Now what we can do is actually set our location. So if the object is overlapping our collision box, we're going to set the location to the same as the fuse location 1. So fuse checks to see if it's touching the box. If it is, we're going to set the location. So if we drag off, you'll remember that we actually added the location and rotation to our pickup interface, which is also inherited by the object. So pickup actor interface, we have it here. And if we open that up, it's the exact same one. We're just going to set this information. And in this case, we know that our fuse that we have selected will have that interface. So we can drag off and we can go drop. You'll see we get drop message, which is from our interface. And we can set our location and rotation. And to do this, what we're going to do is we're going to use the fuse location 1. So we drag this off. We're going to get we're going to get world location, and we're also going to get world rotation. Because in this case, you might want it so they rotate in specific directions. They could be horizontal, vertical, but you might want to choose that specifically. So we just set location and rotation. And that should be it. It should now, once we pick up our fuse in the overlap, they will snap into location. So just to cover what we've done in our code, we have two blueprints, our fuse and box. We also have our pickup actor interface, which comes with a default template, which has our set location and rotation. So our fuse box checks to see if our fuse blueprint, which we're selecting in the scene, is overlapping with the collision. If it is, it's casting to the fuse and it's setting that is fuse connected. So this one, if that's true, we're then setting the simulate physics to false, so it won't fall. And then we're setting the actor location, which we're getting through our pickup interface, which is set through our drop message. If you're not too sure about the interfaces, I highly recommend checking out the last video where I cover it in a little bit more depth, and it just makes it a little bit more easier to understand. So we set the location through the fuse, and what we do on the end overlap, why we're using this, is once the object's ended the overlap, we need to set the fuse back to enable physics, because we don't want it to just stay in the air if we drop it when it's not touching the box anymore. So we hit compile and save, and now we can jump into the scene, and if we go to our cylinder and we pick it up, we can actually attach it to our cube and it'll go in the right location no matter which way we put it, and we can actually grab it and take it back out, which is exactly what we want. The thing is now we want to add some more to it, because we can't just go with one fuse. And the best part of this is we've already created the base for this. So if we go into the scene, the only thing we need to do is actually duplicate our fuse. We've duplicated it. Now in our fuse box, we essentially just need to copy this for the amount of fuses. But to do that, we need to actually copy our location first, our collision box. So I'm going to duplicate these twice, and you'll see it goes to the same place. And if we spread these out, we now have 3. Hit compile. So it's as easy as copying all of this, but we also need to find out our 2 other fuses. So we're just going to duplicate our fuse required. So 2, and then duplicate, and then 3. Hit compile and save. And now we can actually copy this code and paste it 3 times for the number of collision boxes that we have. And for fuse location 2, we still need to do the on component begin overlap and on component end overlap. And we're going to hook these up the same way that we did before. And in this case, we need to change the fuse location to our fuse location 2, and the same for fuse required 1. And we can do this by simply dragging and pointing onto the object. Don't do it on the text, do it slightly off to the side, and that will update the variable. So we now got those updated. Might as well do the third one, fuse location 3, and then on component begin overlap and other actor. And now, so we have this 3 times, which works for each collision box. So 1, 2, and 3. And we can go into the scene and we can select our fuse box. And we want to say these actors are going to attach to these fuses. So we'll keep this in order because I haven't changed the color. So fuse 1 goes to fuse 1. Fuse 2 will go to fuse 2, so we'll select that one. And then fuse 3 is going to go to the third location. Hit save and play. So now our fuse on the right is fuse 3, will not go into fuse 1, fuse 2, but it will attach to 3, and then we can do the same and go through. And we can also drag and drop and remove. And you'll see that when I let go now, they just vanish. And the fix for that is if I go through and we find our fuse. So you saw our fuses vanish. That's because I made a mistake on our bool. So we need to make sure that our is fuse connected is set to false to begin with. So when we let go the first time, it'll simulate physics. But we also need to make sure in our fuse box that on release, we set our fuse to not connected, which is something I forgot to do. What it's trying to do is update the location and rotation of the object when we haven't actually set a position to begin with. So it goes to 0, 0, 0 the very first time. So now if we drop back in after fixing our mistakes, we pick it up and we can actually drop these and pick them back out. And they'll interact with the world in the scene, which is awesome. But now we can actually cover how to turn the little light on. So as mentioned, if you watched the previous video, you'll already know how to do this. But what we're going to do is we're going to create a new blueprint interface. This blueprint interface, you're just going to right click, go to blueprints and blueprint interface. We'll call this BPI underscore win for this example. And in here, we're going to we'll just set it to win for this example. And we're going to give this a integer value called required. And we'll call this required value. So what we're going to do is we're going to send a number through this interface, and then we'll activate it. So if we go back to our fuse, box, we'll do BPI win message, and we're going to set this value to +1. Actually, it'll just be 1. And then once it's been removed, we're going to set this to -1. And you'll notice that we actually need a target. We don't have one of these set up, so we're going to create another actor reference, which will point towards our content which has our function in it. So our win. This could be a door you want to activate, could be text, a sound effect, you name it, anything it can be done as long as you point towards the right object. So rename, we'll call this activate. We want to make sure this is an actor as well. And this is something we'll set in the scene. So drag this in, get activate, and we'll plug those in. And let's copy these down and hook them up to the right thing. Excellent. So we have our fuse location 1, fuse location 2, and then the third. Okay, compile and save. And now we actually need an actor which we can activate to win. In this case, I'm just going to call this, I'm going to create an actor and I'm going to call it sphere, or actually we'll call it BP underscore win. We'll hit enter. And the first thing we're going to do is add our new interface that we created. So our BPI win. Let's do win, hit compile and save. And we need a object. So I'm going to do a sphere, if I can spell it correctly. Hit compile, and now we can drag this into our scene, and we can select our fuse box. And we don't have our thing available. That's because I forgot to make it public. So we go to fuse box. Anything that we want to activate once all the fuses are in are going to be selected from here. And now we can select the actor in the scene, which it will now send this information to. Well, let's save. We close these other windows because we don't need them anymore. We can go to our win blueprint, or your door, your anything at all, and we're going to implement our interface, which we already did. And what we want to do is we're going to right click, go to event, and search win. And you can see here we get our value. We want to add this to a number. So we're going to do a little bit of math, and we're going to right click. Actually, we'll right click, we're going to promote to variable, and we're going to call this value. Doesn't need to be public, but we do need to compile so we get it. And we're also going to get a reference to it. So anytime this is fired, we're going to add the number that comes in to our value, and then we're going to get our value so it adds to it. So it just goes around a little circle. What we're then going to do is we're going to create another variable called points required, and we'll call this an integer as well. So what this is going to do is, if we set it to public, it's going to let us choose how many things we need, or how many points we need to activate it. In this case, we've got 3, but what I could do is I could make as many of these as I want just by duplicating the code. So I could have 5, and then we can set this here to, if I hit compile, so we can see it, I can set this to any number as long as we have the score going into it. So our case is 3, but it could be anything else. But then I'm going to drag off, and we're going to do a branch, and we're going to check that the points required is equal to the value that we have. So equal points, and then plug them in. And now what we can do is we can do something super simple. In this case, we'll just change the material. In this case, what we're going to do is go to our sphere, and by default, we'll set this to red, so it's off, or orange. And we'll do if true, so if it has the points, we're going to set material for our sphere. And we'll set this to, let's say, green. And if it's false, we'll be setting it back to our red. So if we scroll down, basic asset 01, make sure our target is correct. And now, if we hit save and play, we can jump in and we can attach our fuses or objects, and you'll see that it actually changes the color based on the amount of fuses that are in our puzzle. So that's pretty much it for the coding side. What I'll do is I will show you how I actually attach the objects to it in the other example. So the one that I've been using as a reference. Don't forget, if you're a Patreon, you can actually download this project to jump in and try out and use it however you want. But what we've got is our fuse box, which is exactly the same. So it's just the same code, nothing's different. And all I've done is actually set our fuse box, or all I've done is set our static mesh to the fuse box. I did have to scale it up, but that's pretty much it. And then I'm going to hit compile and save for that one, just because I reset the collisions. And now in the fuses, what I did here is in the construction script, I actually set the static mesh. So I've got a default fuse model, and then I've got a new model which I can set. So in here, I just have it so I originally had some text that you could read, but then I can actually set the mesh to something new. That allows me the option to have one fuse do multiple different things, or one blueprint control everything. So now we can jump back in, go over to it, and we can pick these up. And since I put the collision back on, we can actually interact with the object. Oh, if I don't punch a computer screen, we can put these in and it'll light up. So I really hope you enjoyed this, and I'd love to see how you implement it into your own projects, especially with it being so versatile and how you can set up. And I'd love to see some puzzles that you do. If you do create any, please head over to the Discord. We've got almost 500 people in there now, and it'll be awesome to see how you're implementing it. Show us an example. This video was brought to you by Patreons, as it's their contribution that makes this possible. So if you do want to help out or even get access to this folder or project, then head on over there. It's all available for the £5 Patreon. It's just a template that I've been working on, so you can see here what it contains. Custom hand animations, Quest desktop screen fade, interactable location. So you've got loading screens for future tutorials, which will be coming soon, as well as the lightsabers and gun stuff. So yeah, until next time, I hope this helped you all out quite a bit, and I'll see you then. Stay safe. Bye.